Hello student, welcome to our physics discussion, that is physics in a smart way. Today we consider a question in capacitance. We got a parallel plate capacitor filled with dielectric, and our basic job here is to find the value of the capacitance. That we'll be doing in two ways. Before that, first of all, let me show you the question and the diagram and the related details. Okay. Okay. So it's our question that is on your screen, which says, find the effective capacitance of the system, parallel plate system, and you consider that capacitance C equal to, it is epsilon naught A by D, A divided by D. So the thing that you got with you is a parallel plate capacitor whose plate area is A, that is being divided into two parts, equal parts, that is A by 2 and A by 2. The spacing between the plates, in between the plates is D, that is also divided into two parts, D by 2, D by 2. And different dielectrics, they occupy the position whose dielectric constant or relative permittivity is given. This portion is filled up, that I have shown you in red dots, has got a dielectric constant or has got a relative permittivity 2, and this portion has got a relative permittivity 3. Similarly, this is having the same permittivity, same relative permittivity, that is 3, and this portion has got a relative permittivity, that is 2. So two different dielectrics are used. They occupy the 4 positions shown in the space. Each dielectric occupies, that is 1/4 of the space between the plates. A by 2, and this is D by 2 and D by 2. Initially, when there was not a single dielectric, the capacitance was completely empty. So the entire space having the area, that is A into D, was occupied by, you may say, vacuum or air. And that capacitance was it is epsilon 0 A by T. You have to consider that we are clubbing it up, that epsilon 0 A by D at C. So initially the air capacitor, the complete air capacitor was of capacitance C. Now, as because we have got 4 spaces filled up by 2 different dielectrics, you have to find the new capacitance or effective capacitance of the combination. Again, I am repeating, these 2 and 3, these 3 and 2, they refer to the relative permittivity or dielectric constants. Okay, so now when you go for solution of this question, it is of intermediate level. Usually, without going to the most fundamental analysis, we do what? We try to solve this question with the help of our capacitance combinations, that is series and parallel combination. We consider this whole capacitor as a group of series and parallel combination. I am showing you the solution in 2 different ways. You have to think of the case, and at last we'll be concluding. So if we see a student going by a method, that is method 1. That is method 1. He or she goes for dividing this capacitor into a system, series parallel system, that is like, I am showing you. Let us come back to our method 1. So the whole capacitor, which is filled up, which is broken into 4 different zones occupied by 2 different dielectrics of dielectric constant or relative permittivity 2, 1, 3. Here it is 3 and 2. The whole capacitor is broken into 4 parts. And this group of capacitor, this entire capacitor can be shown to be 4 different capacitor. They are connected in series and parallel. The first part, it is having dielectric constant or relative permittivity, that is 2. The first part is in series with the second part. It's the idea of the student who is following the method 1. Similarly, the third part is in series with the fourth part. The first second, the series combination of first second and the series combination of third and fourth, they are in parallel, as you can see in the diagram. This is C1, that is C2, this is C3, and that is C4. Okay. But first of all, we try to decide on one thing. The entire capacitance, when there was no medium or air medium was there, air is same as vacuum, as you know very well, was having a capacitance C, and C equal to epsilon naught into A by D. Now, if you try to imagine a capacitor which is also an air capacitor and just 1/4 of the original one, then that capacitor, it is shown here. So its capacitance is C dash. That capacitor will be having the area which is half of the area of the big capacitor. And the spacing between the plates will be D by 2. And that is obviously is an air capacitor. So if you try to find the capacitance of the air capacitor, then let us say that capacitance equal to C dash, then C dash. And you have to keep in mind, I am talking of air capacitor. Dielectrics will be coming in later on. So C dash equal to epsilon 0 into the area of the full area of the plate is A by 2 divided by the distance. We know distance, that is the gap between the plates, is D by 2, of course. 2 cancel out. So then capacitance becomes, that is epsilon naught into A by D, which is the capacitance of the original big capacitor and which was equal to C. So C dash is equal to C. Now come back to the method 1 in a full-fledged way. So student considers this portion and which is having relative permittivity 2 and that portion which is having relative permittivity 3 as a series combination of 2 capacitors. I have marked them as C1 and C2. You can clearly see those relative permittivities are present, dielectrics are present. This is 2, this is 2, this is 3, and this is 3. And below we got this relative permittivity is 3, and that is 2. Those are C3 and C4. And the C1, C2 series combination, C3, C4 series combination, they are arranged in parallel. So if you now try to ascertain the value of the effective capacitance between the extreme ends or extreme terminals, we know because C1 and C2, they are in parallel, and C1 has now got a dielectric 2, got a dielectric or relative permittivity to 2. So this capacitance will be equal to 2C, because the moment you bring in a dielectric or relative permittivity, that is K or epsilon R, into an air capacitor, you know capacitance goes up by that many times. If initial capacitance was C and now a permittivity comes in and fills up the space, then the new capacitance will be equal to epsilon R into C. Similarly, the second capacitor C2 in our terms will have a capacitance that is 3C. Similarly, C3 will have a capacitance that is C3, and C4, as because the relative permittivity is 2, will be having a capacitance that is 2C. So now our job is to find out the capacitance of a group where in the upper branch, we got 2C and 3C, they are in series, and here 3C and 2C, they are in series. Okay, this group in series will be giving a certain capacitance, and that will be same as the capacitance of this group, because the same two capacitors are utilized here. Okay, you know C2 is same as C3 and C1 is same as C4, and doesn't matter in case of a series combination which one is first, which one is second, or which one is in front and which one is connected to its back. So, and when two series capacitors are there, the effective capacitance will be equal to C1 into C2 by divided by C1 plus C2. I am employing the formula that 1 by C equal to, you know, that is 1 by C1 plus 1 by C2. So utilizing this formula, we know two capacitors C1 and C2, they are in series. The effective capacitance C will be equal to, or C dash will be equal to C1 into C2 by C1 plus C2. So if I combine these two, these two will be giving us an effective capacitance that is 2C into 3C divided by 2C plus 3C, that is 5C. So that capacitance will be equal to 6C by 5. Similarly, the capacitance of this group will be equal to also 6C by 5. I think you follow me. So now the upper branch has got a capacitance of 6C by 5 and the lower branch has got a capacitance of 6C by 5. And because they are in parallel, in case of capacitance parallel combination, you just add the capacitors, and the formula is if C1 and C2 they are in parallel, then effective capacitance equal to C1 plus C2. So thereby, because both the branches, the upper branch and the lower branch, they are in parallel, so total capacitance will be equal to, 60 by 5, 60 plus 60 by 5, so that will be 12C by 5. Did you get me or not? If you didn't get me, then you can write in the comment section. So effective capacitance equal to 12C by 5. I couldn't do it methodically because we lack in space. A lot of diagrams are there and all those things. So thereby, I think we have followed it. Now, we go to the second procedure or method 2. Another student is going for the same question. And he or she follows the similar series and parallel procedure, but in a slightly different way. Let us see. And then finally, we'll be able to compare. So let me remove and put in. Okay. So now we go to the method 2 or the way of the second student. He or she take the system has to be a combination of C1, C2, and C3 and C4 like this. C1 and C2, C3, they are in parallel. C2 and C3, they are in parallel. And this parallel combination is in series with the second parallel combination. Obviously, as you know, C1, because it is having a dielectric or relative permittivity, that is 2, will be having a capacitance of 2C. And that will be obviously, we have known it before, that is 3C. This is having a capacitance of 3C, that is C3, and C4 will be having a capacitance of 2C. Because C1 and C3, they are in parallel, so the effective combination of this group will be equal to 2C plus 3C will be having a capacitance which is 2C plus 3C, that is 5C. And similarly, this group also having the 2C and 3C parallel combination, that is 5C. And now we got the 5C and 5C, they're in series. So effective capacitance will be equal to, C effective will be equal to that is 5C/2, because you know, if two capacitors C having capacitances C and C, they are in series, effective capacitance becomes C/2, using the formula that 1/C equal to 1/C1 plus 1/C2. So here in the second case, or in method 2, we get the capacitance as 5C/2. But in the last case, of the method 1, you are having a capacitance of 12C/5. If you try to find the values numerically, if you convert this fraction into so to say decimals, we know their values will be close, but their value is not exact. So method 1 gives a value of 12C/5 and method 2 gives a value of 5C/2. One of them has to be correct, other will be wrong. Of course, I have taken the dielectric constant values to 1C, and this is 3 and 2. If I take altogether different dielectric constant values, drastically different dielectric constant values, the answers, they will never match. So now your job is to think about the case and find out which procedure, which method 1 and method 2 is a correct one, is the procedure to be followed, and which method was wrong, and why it had become wrong. So thank you for today. This is the task for you, and we shall be meeting again for another video. So that's all for today, and thank you again. Please like, subscribe, end meeting कर देली, stop ना करिए, end कर देली, stop, हाँ?